Irrational numbers. We know that rational numbers and irrational numbers together constitute real numbers. Square root of 2, square root of 3, square root of 5, etc. are irrational numbers. This type of irrational numbers are called algebraic irrational numbers because they are roots of some algebraic equations. Addition of rational number and irrational number is an irrational number. Multiplication of irrational numbers with non-zero rational numbers is irrational numbers. Non-zero irrational numbers cannot be expressed in P upon Q form. But we cannot prove every rational as irrational number by using this form. Pi and other similar numbers are irrational numbers. They are called transcendental irrational numbers. Before we prove that square root of P is irrational, let's see following theorem, whose proof is based on the fundamental theorem of arithmetic. Result: if a prime P divides A square for A belongs to N, then P divides A is greater than 1. Let the prime factorization of A be as follows. A is equal to P1, P2, so on up to Pn, where P1, P2, so on up to Pn are primes, not necessarily distinct. Therefore, A square is equal to P1, P2, so on up to Pn into P1, P2, so on up to Pn is equal to P1 square, P2 square, so on up to Pn square. Now, we are given that P divides A square. Therefore, from the fundamental theorem of arithmetic, it follows that P is one of the prime factors of A square. However, using the uniqueness part of the fundamental theorem of arithmetic, we realize that the only prime factors of A square are P1, P2 up to Pn. So, P is one of P1, P2 up to Pn. Now, since A is equal to P1, P2 up to Pn, therefore, P divides A. Example: if P is a prime number, then prove that square root of P is irrational number. Proof is as follows. Suppose square root of P is equal to A upon B. GCD of AB is equal to 1. A belongs to N, B belongs to N. Therefore, A square is equal to PB square. Therefore, P divides A square. Therefore, P divides A. Suppose A is equal to Pm. M belongs to N. Therefore, A square is equal to P square M square. Therefore, P square M square is equal to PB square. Therefore, B square is equal to Pm square. P divides B square. Therefore, P divides B. Therefore, P divides A and P divides B. But GCD of AB is equal to 1, which contradict our assumption. Therefore, square root of P is irrational number. Example: prove that square root of 5 plus square root of 7 is an irrational number. Proof is as follows. Suppose x is equal to square root of 5 plus square root of 7 is an irrational number. Therefore, x square is equal to 5 plus 7 plus 2 into square root of 35 is rational number. Therefore, x square minus 12 upon 2 is equal to square root of 35 is rational number. If possible, then suppose that square root of 35 is equal to a upon b, where GCD of AB is equal to 1. A belongs to n, b belongs to n. Therefore, a square is equal to 35b square is equal to 5 into 7 b square. Therefore, 5 divides a square. Therefore, 5 divides a. Suppose a is equal to 5a1. a1 belongs to n. Therefore, 25a1 square is equal to a square is equal to 35b square. Therefore, 5a1 square is equal to 7b square. Therefore, 5 divides 7b square. But GCD of 5, 7 is equal to 1. Therefore, 5 divides b square. Therefore, 5 divides b. Therefore, 5 divides a and 5 divides b. It is contradict to our assumption because GCD of AB is equal to 1. Therefore, square root of 35 is an irrational number. So, x is equal to square root of 5 plus square root of 7 is an irrational number. Second method. If x is equal to square root of 5 plus square root of 7 is a rational number, therefore, x minus square root of 5 whole square is equal to 7 is a rational number. Therefore, x square minus 2 into square root of 5 x plus 5 is equal to 7 is a rational number. Therefore, square root of 5 is equal to x square minus 2 upon 2x is a rational number. But square root of 5 is an irrational number. Therefore, x is equal to square root of 5 plus square root of 7 is an irrational number.